review of Algebra 1. For today, we're going to be talking about solving linear equations. Rule number 1, you must have a variable that is isolated, meaning all by itself. I'm pretty sure most of us know that an equation isn't done if it's not x equals blank. That is like the number one typical math thing that people look for is an answer like x equals blank. So that is one thing. Second thing is make sure that you are using opposite operations. And I'm just going to call them opposite ops for now. You can write operations all the way out if you like. What I mean by that is when you are trying to move something to the other side, you have to use an opposite operation. There is a scenario when we won't use these, and I'm going to kind of make a little note of it underneath, and that is except like terms. Okay, what I mean by that is we are going to combine like terms. And when we do that, we don't need to do the opposite. We'll see that when we get to example number 2. And then whatever operation you do, you must do it on both sides. Okay, pretty sure that those are good Algebra 1 rules we all knew. Maybe we forgot some of them. Maybe we just need to be reminded to be careful about them. The right half gets a little bit different. These are just extra things that might jump in your way. Whenever you see a number in front of parentheses like this one or the bottom 2, actually all the bottom 3, you're going to distribute. Distribute is the correct term for that. You're basically multiplying when you do that. So if you call it multiplying, you're not really wrong. Distribute is just what it's called when we deal with the parentheses, because your first goal, if you see parentheses, should be to get rid of them. The only catch with this is, for example, with this 5, that 5 is going to get multiplied by the 9 and the x, but not the 11, because the 11 is not part of that parentheses. So just make sure you're paying attention and you stop when you get to the end of that parentheses. And then lastly, equations can have multiple types of solutions. They can have one solution, no solution, or infinite solutions. And I'm going to kind of remind you how all 3 of those pop up. We will never write one solution as our answer, like the words one solution, because instead of telling me one solution, I want you to tell me what that one solution is. So when you say things like x equals 3, that's telling me there's one solution and that solution is 3. Keep in mind that we're really just looking for what number goes in for this letter here and here, so that whatever is over here actually equals whatever is over here. It's kind of like that activity. You were just trying to make it equal each other on both sides. We're still doing the same thing. We use letters as placeholders because we don't know what number they are yet. So we're trying to find that by working backwards. I'm going to kind of jump right in. I'm going to go a little bit faster than I would if we were learning something new. I want my variables on the same side. That's where I'm going to start with because I don't see any parentheses and I don't see anything on the same side that is the same type of term, like both plus or both just numbers or both just x's. So I have a positive 4x that I'm going to subtract on over to the other side. The 13 and the 37, those guys are staying exactly where they're at. This one just kind of goes away. That is an opposite operation. 2 steps left. Add the 13 to the other side to get rid of it. Always get rid of this before this. I tell my Algebra 1 kids it's like putting on your shoes and socks and then taking them off. When you go home, you can't take your socks off before you take your shoes off because your shoes are literally in the way. This is in the way of this. You can technically divide by 4 first, but you would have to divide everything by 4, and that's going to create some ugly fractions. So instead, simplify your process by adding the 13 to the other side first. And then for some of us, all of those bells and whistles start going off because we know that 4 does not go into 50. And that's totally fine. We're still going to divide by 4 on both sides. Anytime there's a number in front of x, you're dividing by it at the end to get rid of it. And I'm okay taking care of this one for you this time. It is 12 and a half. You can write 12.5, you can write 12 and a half, 25 halves, whatever floats your boat. Okay, all in the process of getting x alone. On the middle, I'm going to multiply by 5 first. Don't let the multiplication be what gets in your way. If you're not sure what 9 times 5 is, you may use your phone calculator for right now. I know that I do not have calculators sitting out yet. Hopefully I will soon, once we kind of establish what's going on there. I'm trying to avoid giving you guys my calculators from last year. And then we've just got to solve from there. Over here, I don't have parentheses anymore, so I'm clear there. But I do have 2 things that are the same type of number. They're both numbers without x's. Those are like terms. We can put those together. But notice, 45 and 11 are on the same side of the equation. So you don't have to do the opposites. These 2 are just going to combine. And I'm not going to write that every single time, but I am going to write it this first time so that you know I'm not adding that 11 over. It's already together. I just literally need to do 45 minus 11 like it looks, which is 34. And then I'm going to keep my plus 5x and my equals 59. That is the number one mistake I see Algebra 2 students make when we're reviewing some of our Algebra 1 stuff, is that you don't change those signs if they're already together on the same side. You do have to change the sign when you want to take this number and get rid of it on this side and move it to the other side. If it's going to the opposite side, it needs an opposite operation. That's not moving to the opposite side over here. Now I want to get rid of the 34. So I do have to switch to my opposite because I don't want it on this side. I need to move it to the other side. And 59 minus 34 is 25. Divide by that 5 on both sides, or if that's not your brain, if your brain is the type that's like 5 times what is 25, power to you, do it. If that's how you want to solve equations, go for it. I'm not super picky on this part because I need you to be able to do this easily. I need this not to be the kind of thing that's going to trip you up later on. So you find a way that works for you. Some of our brains think less of it like balancing and more just like, what number could I put here to make this true? Almost like that make 6 activity that we just did, where we're just like figuring out what goes there to make it fit. Okay, and then this third one is our first special equation. What happens is we get to add these 2 together because they're already on the same side. There's no equal sign in between those 2. So we're just adding together 8x and negative 5x, which makes 3x. There's 2 ways of thinking about this next step. The first way is just noticing you've got 3x on both sides. So automatically when I go to subtract this one, because they're on opposite sides, they're both going away. And now we have this weird equation without x's left. When that happens, when you don't have x's, you just need to ask yourself, is this true? Does 11 equal 7? No. So it's no solution. I see a couple people squinting, so I'm going to zoom in. 11 equals 7 is not part of your answer. I'm just writing it there because that's what's technically left. If you get something that does not make any sense at all, like 11 equals 7, that's no solution. And I'm going to skip around a little bit and move to the middle bottom in a second so that I can show you what infinite solutions look like, which is essentially 11 equals 11 instead of 11 equals 7, if you actually get something that makes sense. Okay, any questions so far? I know it was probably kind of a scramble for some of us because I was going a little faster. Okay. All right. There's a little bit of distribution on these. They look harder because, well, there's distribution that needs to be done. Number one tip, if you see distribution that needs to happen and you're not sure what to multiply, like right here, there's no number in front, put a 1, and then I'm technically multiplying both of those by -1. Be very careful with that because what happens is that changes this into -1x, and -1 times -12 turns into +12. I feel like that could very easily be accidentally left a -12 by some of us. It happens. And then over on the left, or very far left, I'm multiplying by 3. And you can kind of do it in whatever order you want. Maybe you started with the multiplying by 3 because you saw that first. I started with the -1 just because I knew that that was tricky. And then you've got to add your like terms together. If you feel like an equation is looking extra long, look for things like this that you can already add together without really changing anything about the equation. 6x and -1x adds to 5x. And this is the part where you have to be a little careful. 12 plus 12. They don't cancel out. Yes, they're the same number. Your brain's going to notice that, and you're going to think, ooh, I really hope those cancel out to make my life easier, but they don't. And then subtract it and divide. 34 minus 24 is 10, and 10 divided by 5 is 2. Now, I am not super picky about how you show me your work. It just needs to be there in some form. For instance, I didn't show you my division by 5. Fine, guys, you've earned that right, being in Algebra 2, not to write your little over 2 on both sides. Unless that is something that you need to follow your own work. Because while it, yes, is important for me to be able to see it so I know if you know what you're doing, if you can't understand your own work, then you're just doing work for no reason if you can't look back at it and decide what in the world is going on. I'm going to multiply by this 3 out front on this first parentheses, 6x and 27. Everything else afterwards is the same. Minus 3x equals 3x plus 27. It is also okay to cross two things out and rewrite it. So if I wanted to add these two together because they're like terms, 6x minus 3x is 3x. And I can kind of just do it like that if I want to. There's just multiple ways of showing your work. I feel like sometimes we get a little too rigid and trying to do it exactly the way our teacher showed us. We don't feel like we have the freedom to write it the way we want to. Things like that will save you a lot of time because sometimes we're doing equations that take 7, 8, 9 steps in Algebra 2. What I notice now is that 3x plus 27 is equaling 3x plus 27. It's the exact same equation, guys. When that happens, you have infinite solutions. If you've heard it as all real numbers, that's fine with me as well. If you don't know what that is, fine. I'd rather use infinite solutions. They don't really care. Because these 3x's will cancel, and you have 27 equals 27. That's true. I know this is kind of long because we're solving 6 different equations, but each one kind of has their own thing. This last one is probably the most important to put with these two, because what happens is you're going to multiply and get 5x plus 15 equals 4x plus 15. And again, your brain's going to catch things like, hey, there's a 15 on both sides. It's natural to notice that, but it's not the same number of x's. I can still subtract my 4x to be with my 5x without canceling it out on both sides. It just makes 1x. So long as your x's don't completely cancel, you have to have an answer. So when I go to subtract this 15 to the other side, and all of us somewhat naturally kind of go on high alert because we're about to get a 0, that's fine. X equals 0 is our answer. It is a perfectly valid answer, just the same as 1, 2, 3, and 4. It is a value. It just freaks us out a little bit because it's technically nothing. Okay, and then I'm going to kind of go a little bit slower on setting up the equation for this word problem at the bottom, and then I'll solve it pretty quickly. I am signing up for a streaming service called Mathflix. There is a limited time deal where new members pay $25 up front and then $3.75 per month. When you read something like this, translate it directly into math. Keep the 25, keep the 3.75, and figure out which one is variable. Which one isn't just a set number. The 25 is a set number. They're going to charge me at once. I'm never going to see it again. It just happened that one time. It was 25 and now it's done. The 375 comes back to haunt me every month that I forget to cancel my subscription if I don't want it. That's the one that needs to get a variable with it. And I'm going to add those together because they are both parts of my cost. And I want to figure out how much I can buy with $80. That's my grand total, guys. Word problems in math class aren't really that different. It just changes the situation. I know there's some decimals in this one, so I'm going to go ahead and let you know that after you subtract this 25, you're going to get 55. Meaning, after I take out my $25 up front, I have $55 left to spend. I need to figure out how many months that will get me at $3.75 a month. When I divide by $3.75 on both sides, no, this is not a typo. This is the way the problem is supposed to work. You end up getting 14.6 repeating. How many months can I buy? 14. Can't buy the 15th month. I don't have enough. So sometimes when you're trying to budget something, your budget comes out to be that you can buy 14.6 months. But no way is Mathflix going to let me buy 14.6 months. However, they will just say, hey, don't spend your whole $80. Go ahead and just buy 14.